So everything in today's lesson should all be review. This is nothing new. You learned this in 7th grade. Your teacher even might have used this exact paper to kind of explain it to you in 7th grade. So first thing is, today we are talking about proportional and rate of change. Mostly in our workbook it's going to be rate of change, but I want to refresh our memory on what proportional means too. Okay? So proportional is when we're using just the numbers in the charts because we're just doing y over x. So we're using these numbers. So in the first one, is this table proportional? Well, if I do my y over x, I have 3 over 1. That simplifies to 3. Then I have 6 over 2. That simplifies to 3. And I have 9 over 3. That simplifies to 3. Since they are all equal to each other, each one, the ratio of y to x, is equal, that means yes, it is proportional. And you might remember from last year, if there was a constant unit rate or a constant ratio, we called that our constant of proportionality, and that was our k value. So in this case, k is 3. On the second one, we're going to do the same thing. Proportional means y over x. If you forget, it's always at the top of this page. So I'm going to do 3 over 1. That's 3. The second one is 5 over 2. That's 2.5. And the last one is 7 over 3. That's 2.3 repeating. These are not equal to each other. Since they are not equal, it is non-proportional, or no, it is not proportional. So there is no k value because there is no constant unit rate. Okay? The next part says, does it have a constant rate of change? Well, for our rate of change, what we are talking about is this triangle y over triangle x. That triangle is a Greek letter, and that we say it as change in y over change in x. That means this time we're not using the table numbers, we're looking at how those numbers change. So the first time around, my y changes by 2. Actually, I'm sorry, let's start with this one. So I'm doing my change in y over change in x. And my y is changing by 3 when my x is changing by 1. So it's a 3 over 1. Then the second time, from 6 to 9, it's changing by 3 for my y, while my x is changing by 1. And I'll wait for that to focus in so you guys can see it. Okay? So my y is changing by 3 as my x is changing by 1. And you can see I kind of color-coded the numbers. This is where the first fraction was as my y changes, my x changes. The second set, as my y changes, my x changes. And each of these simplify to 3. So does it have a constant rate of change? Yes, it does. The constant rate of change is 3. Okay? On the next one, as I do my change in y over change in x, and we're doing that because it's constant rate of change, so we're asking for the rate of change. We're doing our change in y over change in x. So my change in y on the first set was 2, while my change in x is 1. That simplifies to 2. Then the second set, 5 to 7, my change is 2, while my change is 1. I know those are equal, so does it have a constant rate of change? Yes. That constant rate of change is 3. I'm sorry, 2. I'm writing the wrong thing. I'm looking at the wrong numbers. 2, because every time it was equal to 2. Okay? Now that we've looked at if a table is proportional and if it has a constant rate of change, we want to see what those things look like when we would graph. And you might remember what a graph looks like when it's proportional from last year. So I'm going to take these points, 1, 3, 2, 6, 3, 9, and graph them. 1, 3, 2, 6, 3, 9. And usually we'd use a straight edge. I don't have one out at the moment. Okay, so that's what it looks like when it is proportional. This one, it's not proportional, but it still has a constant rate of change. So these will be somewhat similar because they both had a constant rate of change, but there's going to be one part to these graphs that are different. So if we look at it, we're going to use 1, 3, 2, 5, and 3, 7. So 1, 3, 2, 5, 3, 7. And again, we would normally use a straight edge, but I don't have one out. Okay? So if you look at it, hopefully you're noticing they're both straight lines, but this one goes through the origin, 0, 0, and this one does not go through the origin. So a graph will be a straight line. We say it's linear. If it is a straight line, you can see it has that word line right in it. If there is well, both of them are a straight line. Remember, both of them had a constant rate of change. So a graph will be a straight line or linear if there is a constant rate of change. The next part says the graph will have a straight line and go through 0, 0 if it is, well, this was the only one that was a straight line through 0, 0, and the difference was this is proportional, this was non-proportional. So we're going to say if it is proportional. And then the last part says if the relationship is proportional, we know what things are equal to each other. Well, if you look up here, if we look at our rates when we simplified and our rates when we simplified, they were all 3. So if it's proportional, my constant unit rate, or this constant of proportionality, will be the same as the constant rate of change. So my constant unit rate will be the same as the constant rate of change, which means our our y over x, that's how we found our constant unit rate, is going to be equal to our change in y over change in x, because this one is the rate of change. Okay? This is a really important paper to have. I printed it out on color for you. You want to make sure you have that filled out so you have it for when we would use it, hopefully, on your test. Okay? So this is from the actual book. I think it's page 171, maybe 172. Okay? When we look at it, this is just kind of refreshing your memory of some of the words. We already discussed them. Linear means it's going to be a straight line, and if it is linear, it has a constant rate of change. Okay? So they show an example here, and you can read through that. I want to just go ahead and look down here. So the question is, are these linear? Okay? Are they linear? Well, remember, if it's linear, that means straight line. To be a straight line, there has to be a constant rate of change. Okay? So when we do this, we're going to look at it and we're going to say, what is it changing by? This went down by 5 and up by 5. So my first one would be my change in y over change in x would be negative 5 over 5. That's negative 1. Then my next one, it went down by 4 and it still went up by 5. So that would be negative 4 over 5. Well, that's negative 0.8. I already know those are not equal to each other. So if the question is this linear? We're going to say no. And the reason it's not linear is because there is not a constant rate of change. Okay? And I'm just going to let you know, this is what the first 3 problems on your homework look like. Is it linear? If so, tell me what the constant rate of change is. So you would do it just like this. Make sure you are simplifying each one, because you might have 2 different fractions, but they might simplify to be the exact same thing, in which case they would be equal and there would be a constant rate of change. So the first 3 problems look just like that. Then on the next one, to do our rate of change, it's easiest if we just make a table with our points. This first point is 880, second point 1660, third point 2440. So we're going to look at how it's changing each time. So here went down by 20 as it went up by 8. So that would be negative 20 over 8. Next time, down 20 over 8. So my change in y over my change in x is constant. Each time it is negative 20 over 8. So if it asks if it's linear, we are going to say yes, because there is a constant rate of change of, and we can keep it as negative 20 over 8, or we can say, if we divide it out and simplify, it'd be negative 5 over 2. Okay? These are exactly what 4 through 6 look like on your homework. So I would make a table for them, then show your rate of change. How is my y's changing? How are my x's changing? Okay? The next one, again, just because of time for the video, I'm not going to go through this one. It is very detailed. You can read through it, and it will explain that you need to check if it's proportional. That's this part, your y over x. You also have to check if it's linear. That's this part, checking how it's changing in y over changing in x. Okay? The last example is the same thing as example 2. So again, read that to help you if you don't quite understand this one. So it says, use the table to determine if there is a proportional linear relationship between the mass of an object in kilograms and the weight of the object in pounds. Now, if you haven't noticed yet, normally when we have our tables this way, it's always x and then y. In this case, when we look at it, it's usually x and then y. Just so you know, it also kind of tells you in the problem, we're comparing kilograms in mass to weight in pounds. So we're doing mass to weight. Okay? So first thing I want to look at is, it's asked if it's linear. Remember, linear is rate of change. So we're going to do our change in y over change in x. Well, when I look at this, it changes by 9 each time. This changes by 20 each time. Oop. So my change in y is 9 over my change in x will always be 20, because I found that it's the same on each, so they always simplify to be the same. Since there is a constant rate of change, yes, it is linear. So we're going to say it is linear because there is a constant rate of change, and that constant rate of change is equal to 9 over 20. All right. And the last part here is it proportional? Remember, proportional, that's my y over x. Let's hope it focuses for us. So that would be our 9 over 20, 18 over 40, 27 over 60, and 36 over 80. And you might be able to notice that if I did this divide by 2 and divide by 2, it would be 9 over 20. Divide by 3, it'd be 9 over 20. Divide by 4, it would be 9 over 20. So if we look at this, it has a constant unit rate, so it is proportional. So we're going to say it is proportional because there is a constant unit rate. And that constant unit rate is 9 over 20. So now we would be able to talk about what this graph would look like. Since there's a constant rate of change, it is a straight line. Because it's proportional, we know it is a straight line, plus it also goes through the origin. So that was stuff that we learned from this paper. Remember, if it is a straight line, there is a constant rate of change. If it's proportional, we know it's not only straight line, but it also goes through the origin. So that's how I knew what my graph would look like here. The last part is, remember, if it's proportional, that constant unit rate and the constant rate of change are equal. And if you notice, both of them are 9 over 20. Okay? So make sure you understand the difference. If it asks for proportional, it's y over x. If it asks for a linear, it's change in y over change in x. Okay? Let me know if you have any questions, and I'd be glad to help.